We're dealing with roots of polynomials here. So the first thing I'm going to write down is that the sum of my roots is equal to minus b over a. I've got a, b, c, and d here. The sum of the pairs is then c over a, and the sum of the triples, in which case is just a triple, is minus d over a. And now let's write that down again, but with our actual numbers. So alpha plus beta plus gamma is going to be minus p over 4. Alpha beta plus beta gamma plus gamma alpha is going to be minus 14 over 4 or minus 7 over 2. And alpha beta gamma is going to be minus q over 4. Right, how to use that? We are told that alpha squared plus beta squared plus gamma squared is 16 and asked to show that p is 12. So to generate this, what I'm going to need to do is take alpha plus beta plus gamma and square it. And then we'll be able to relate it to some of the things that we know. Well, when you do this, you get, of course, you get a double bracket. Then we're going to get alpha squared. We're going to get beta squared and gamma squared. And then we get alpha times beta, but we also get beta times alpha. But in the same way, we also get alpha, wait, no, hold on, beta times gamma and gamma times beta. So there's two lots of each of these. And then also two lots of gamma alpha. We've got gamma alpha and alpha gamma. So you want to be able to get to this fairly quickly, but that's it. You can even check, look, there's 9 terms, which is what you'd expect, because you're going to times alpha by the 3 terms here, beta by the 3 terms, and gamma by the 3 terms. Okay, and that's really useful because therefore, right, we have p squared over 16 here when I square alpha plus beta plus gamma, because alpha plus beta plus gamma was minus p over 4. And that is going to equal 16 that we were given from up here, plus 2 lots of minus 7 over 2. That ends up being minus 7. I'm going to get 9. So p squared is 9 times 16. You could write it as 3 squared times 4 squared to be fair, or 12 squared, 144. But p is then going to be 12. Now, is it not plus or minus 12? We're told right at the start that p and q are real positive constants. So although in theory it could be minus 12 here, we're going to reject the negative. Right, so I can update my equation slightly. I've got plus 12 here, plus 12x squared. We're also given this, and we're asked to find the value of q. Well, let's put the left-hand side all over a common denominator. And over here, I would get beta gamma over alpha. And what you can end up doing is writing alpha beta plus beta gamma plus gamma alpha all over alpha beta gamma. They're the same thing. And that's equal to 14 over 3. Well, I know what the top is, of course, because we've already used it once. It's minus 7 over 2. So I'm going to get minus 7 over 2 over alpha beta gamma is equal to 14 over 3, which means alpha beta gamma is going to be minus 7 over 2 divided by 14 over 3, or times by 3 over 14. And that ends up being minus 3 over 4. So that's not a final answer. Remember, minus d over a, which became minus q over 4, is equal to minus 3 over 4. So q is equal to 3. And finally, without solving the cubic, we're asked to determine the value of alpha minus 1 times beta minus 1 times gamma minus 1. Well, let's multiply it out, but we're going to try and do it in a really quick, smart way. I can see that I'm going to get alpha, beta, gamma from here. And then I'm going to do alpha times beta times minus 1 but I'm also going to do alpha times gamma times minus 1 and beta times gamma times minus 1. So I'm going to get minus alpha beta plus, like this just comes with practice if you don't see it. And then I'm also going to do alpha times minus 1 times minus 1. Well, that would just give me alpha. But I'm going to get the same with beta. I'm going to do minus 1 times beta times minus 1, and I'm going to end up getting this. And finally, I've got my minus 1 times minus 1 times minus 1. Now that gives me 8 terms, which is what I expect, because I get 4 terms from the first two brackets, and then I would times each of those by gamma and then by minus 1. And then we're there basically, because alpha beta gamma is equal to minus 3 over 4. We showed that in the last bit. Alpha beta plus beta gamma plus gamma alpha, we found that somewhere. It was minus 7 over 2. Oh no, actually, we're given it right at the start. So I'm minusing minus 7 over 2. Just be really careful with that one. And then I'm adding the sum of my roots, which remember was minus b over a, because we worked out that p was 12, so it's going to be minus 3. And then I'm minusing 1. If you bring this all together, it gives you minus 5 over 4. Good, slight different variation to roots of polynomial question. I like it.